Welcome back to Nano Productions. In this video, we will be calculating potential energy. So in the last video, we went over the different types of energy, but mainly for this course, potential energy and kinetic energy are the only ones we will be calculating. But then we will also talk about how one energy transforms to the other and the relationship between potential and kinetic energy. So stay tuned. And then in this video, we will be talking about some new vocabulary. So hope you remember them. All right. So here's some vocabulary words right here. So energy is an old vocabulary word, the capacity of doing work. Now these are our new ones. I understand this is a lot and some of these words might be familiar but we didn't know. Alright, so mass is a quantity of matter inside any body regardless of shape or size. Now many people will get mass and weight confused. Just listen. So weight is force exerted on a body by gravity. So if I can go ahead and display that for you guys. So basically mass is what is inside the object, like its original basically mass is basically the original quantity. So like inside a box, you may have so basically if you have 4 foam pieces inside a box, well that mass of that box is the 4 foam pieces. But weight instead is also including the force exerted on the body. So basically how much force is being exerted on a body. So weight is basically what we usually measure. Sometimes if you go to a doctor's office, they will measure your mass, but most likely weight is what is mostly used. Now, we will learn how to transfer mass into weight and weight into mass, so it'll be pretty cool. And gravity is a new word, so it's the natural force that causes things to fall down. Basically, it's the force that's pushing down on it. So that's why we're not flying, basically. Humans can't fly. Alright, so let's look at weight versus mass. So mass is basically the inside quantity of the object, while weight measures the force exerted. Alright, so this is a better representation. I know this is repeat, but still, I want you to get in your mind, mass is the inside and weight is the force exerted. So basically force, how much gravity is being put on that object, basically. So let's talk about acceleration due to gravity. This is a new thing. So the acceleration due to gravity is 9.8 meters per second squared. Now we will be using that when we're calculating potential energy, and this is very required. So basically, you may see it as 10 meters per second squared, but 9.8 is more accurate because it's 9.8 and some digits of decimals. But basically, in short, acceleration due to gravity is basically the speed at which an object falls to the ground when any unit light and has a height of 1. So basically, any unit that is 1 unit light and has a height of 1 unit, it will fall at the rate of 9.8 meters per second squared. Now we will get into speed, velocity, and acceleration soon, but all you need to know for this is 9.8 meters per second squared. You will understand more of this when we get into speed. Now the formula for calculating potential energy is very simple. Potential energy, right here, is equal to mass, right here, times gravity, which is the acceleration due to gravity, which is 9.8 meters per second squared, and height. So it is and height, which is h. Now, when you're doing the calculations, you may think that you'll be squaring this, but you do not square it. Just when you're multiplying, you just put replace 9.8. Watch in the next slide how we solve. But potential energy is measured in joules, by the way. Just in case you were wondering, potential energy is definitely measured in joules. So basically your result is joules. So let's look at this practice problem. The mass is 20 grams for this object. The height is 2 meters. So you want to find the potential energy of the object above. Make sure to have the units as joules. So basically, we want to have our answer as joules. So if we plug it in, this is how it would look like. So you can see our mass is right here labeled. So is our height, and so is our gravitational force due to gravity, acceleration due to gravity. So you can see I did not square or do anything. I just left it as 9.8. That's exactly how we do. So we can actually so now you can actually work on this with a regular calculator. So no issue. So if I just want to load a calculator, okay, let me just quit that. Now if I do calculate, so you can see the answer, which is fine. Let me just smaller calculator. We can literally solve. So if I can literally do this on a basic function calculator. 20 times 2 times 9.8. We should hopefully get something similar. 392 joules. Alright, I just added joules. The calculator doesn't tell you what that. Alright, let's continue. So 392 joules should be answered. Now try this problem on your own. Now, this is a word problem, definitely. But let's see how well you do, because you can actually pull out some information. Alright, so let's just pretend that you actually solved it, or if you did actually solve it, you actually did solve it. So let's look at this. So let me get my pointer. So the height is 9 feet. That's it. And so it's a 45 grams. So we got our mass and the height here. So now we just have to plug in the gravitation due to potential energy, acceleration due to gravitational force. So 45, which is our mass, 9 feet is our height, and then our 9.8 centimeters is the acceleration due to gravity. So your answer should have been 3969 joules. Alright, so you can practice with these problems definitely. I will have the answers posted soon enough, and I'll actually share these answers with you in the next video. But these questions are basically reviews. So you have two questions similar to, so this is similar to this question right here. And then this number 3 is similar to this one. Alright, I basically just took the format of these questions and made these practice questions right here. So practicing yourself will actually identify your weakness. So if you have a problem where you don't understand something, then you can easily fix it at this point. If you have any question, please make sure to use the comment section. The comment section has recently really quiet. So I want some discussion down there. Alright, see you in the next video.